Hey guys, welcome to this. It's gonna be a great video. This is a great subnetting video, so if you guys are interested in learning subnetting, I'm gonna go through the steps. I'm not gonna get into it like fully, but I'll cover all the steps needed to answer these questions here. So what I have here on the right is my Cisco exam CD. It's just like a practice exam. It's just for the CCENT. As you can see, I got 139 questions, and I've been going through them question by question, so I believe this is like video 3. But this is going to be a great video. It's going to be pretty long, so bear with me, but we're going to go step by step on how to answer these questions. So what the diagram is implementing here is that obviously everything's set up, all the routers are set up with RIP version 2. And they have the no IP subnet 0 command, as you can see right up here. Okay, and what that command issues is when you're looking at the network, and you know, like if your network goes up by, let's say 32, you got your 0 network, then your 32 network, your 64 network. You just can't use any hosts in that 0 network. So you can't have like 192.168 0.1 as an address. You have to start at 192.168.32.1, for instance. That's what the no IP subnet 0 means. And what they want to implement is just routing between all the networks. So these are all LANs here, as you can see. There's a LAN right here, there's a LAN there, there's a LAN there, there's a LAN there, and these are even considered LANs. Okay, so in this diagram we have 1, 2, 3, 4, 5, 6, 7 LANs. So just to show you what a LAN is anyways. And they just have a series of questions. So out of these questions, what ones are true? So for question A, new PCs that are added to the LAN off router 3 can use any IP address between 192.168.200.129 and 192.168.200.190. So router 3 is this router here, so this is the network. So you want to identify the subnet mask here. So it gives us a 28. So their network is 192.168.200 and the IP address is 141. So when you do your subnetting and you figure out which network they're in, the address has to be within that network. And that's what you would configure PC3 with, okay? Or any PC that connects to this router. So what we're going to do is I'm going to show you guys my little cheat sheet that I have. And this really helped me with subnetting. I'm only going to show you the Class C version of it, because we're going to be dealing with Class C networks here, as you can see at all the subnet masks. So what I do is I always start off with, yes, I'm using Microsoft Paint, but who cares? I always start off with my bit values. So if you have any idea of what subnetting is, you got, you know, your 192.168.1.0, okay? And you'll have a subnet mask of 255.255.255.0. Okay? So what that means is, like, when I say your bit value, I mean any one of, like, these here are octets. I can never pronounce that goddamn word. But anyways, within each of these dots here, you got an 8 bits, and each of those 8 bits has a value. Okay, so you'll have 8 bits here. Okay, so for instance 255 would be ones, 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot, and then 0 means there's no value, so it's 0 0 0 0 0 0 0 0. Okay, yeah, so that kind of implements this here. Okay, so when you're looking at the subnet mask of 28, that's telling you it's the 28th bit. So you got 8, 16, 24, then 25. I'll show you here. You got 25, 26, 27, 28. So with 28, you can see that your network goes up by, well, 16 if you know what I'm about to tell you now. So you list each one of these 8 bits has a value, and that value is what I use to understand subnet mask. So the first bit right here, going from left to right is 128, and then you got 64, then you got 32, then you got 16, then you got 8, 4, 2, and 1. Okay, so that is just like an indication here. Okay, and it just continues on and on and on. So when it says the 28, that means your network goes up by 16 because you are using this network here. This is the last bit. So as you can see here, you'd put your little pipe right here. Okay, so that's telling you your network goes up by 16. If it was, let's say, 27, so this would be your 27th bit here, you'd put your pipe here, and this would be your network. But that's not the case in this video. So it goes up by 16. So you can start listing your networks. So you got 192.168, 200. So you'd go and you'd go 192.168.200.0 through to dot, and what is it, 16? So it'd be 15 because your next address would be the next network. Okay, so your networks are how your IPs are, like, so the router knows, like, okay, so network 16 has the host I need to get to address 16.50. Okay, so it kind of IDs your area here. So the next network would be 192.168.200.16 through 31, because 32 is your next. 192.168.200.32 would be next, and then you'd have dot 48, dot 64, dot 80, and it would keep going on and on and on until you get to 192. So yeah, you're only really missing the 176. But anyways, it's asking if any PC was to join router 3 can use any IP address between 192.168.200.129 and 190. So let's just look for 129. So 129 would be in this network here, right? Because 128 goes to dot 143. But 143 is a broadcast domain, so it's used to broadcast to all hosts in this network. Okay, so that's fine. And 190 is in a different network, which would be in this network down here. Or actually, sorry, it would be in the one network that I left out, dot 176, and that would go up to 191. So right away, like, you don't even really have to go any further, because you can't issue IP addresses in different networks. This network is 141, so it's in this network right here. So it doesn't matter about this network down here. It can't do it. It can only be issued between 129 and 143. So answer A is incorrect. So we can scratch that off the list. So question B, if PC2 were assigned IP address down here dot 129, PC2 could be working if both PC2 and router 2 used a subnet mask of 192. So the default gateway is in 202. So whichever we figure out the network ID of 192, it has to be within 202, has to be in that network range for PC2 to be assigned a 129 network. So to figure out 192, what you do is to figure out the network list is you would add these numbers up. So 128 plus 64 equals 192. So that is the magic number. So this is our network range. So our first address in this example, 10.168.99.0 would be 10.168.99.0, and then .64, and then .128. There's not too many here, so I'll list them all. .192 and .256. Okay, and like the command up here says, you can't use the 0 network, so you couldn't use this one, even though it goes to 63. So that's 63 hosts you lose right there by issuing that command. And it wants to know if you can get 192 or 129. Okay, so 129, looking over here, that's what PC2 were assigned, would be in this network right here, right? Right there. 129. That's the next that's the next ID, so that's fine. But if you look up here, the router is in 202. So the router is in this network. And what's the golden rule? You can't have IP addresses within the same LAN on two different networks. The communication will be lost. So B is also incorrect. So you can't use B. So let's remove this and let's start with C now. If PC2 were assigned IP address .129, so it's pretty much, it wants the same IP address as B, but the subnet mask is different. It's 128. So remember up here how we did the adding? So you don't add because it's 128 plus 64 is 192 plus 32 is 224 plus 16 is 240 plus 8 is 248 and so on. You just keep adding the values. So 128 in itself is just 128. So your network goes up by 128. So you would be looking at what's their IP? 10.168.99.0, and then this network would be 128, and then 128 plus 128 is 256. And you can't use this network, which goes to 127. So it's 127 hosts you lose, right, from that command. And it wants IP address 129. Okay, so that is telling you that 129 is in this network, right? 129 is after 128. And the router has a 202. Well, 202 is in this network. So yeah, that's correct. If PC2 was assigned the address of 99.129 right here, then it could work with router 2. So that's right. Okay, so D, if a new PC, new PCs that were added to the LAN off router 1 can use any IP address between 193 and 223. So again, it's like same kind of question as A. So you want to look at the subnet mask. So D goes up by 32. So your address here would be, because 27, the 27th bit, so 25, let's change that, 26, 27, and the subnet mask is 27, so again, goes up by 32. So your first network is 192.168.11.0, and then it goes on to 32, 64. You guys get the idea, and it goes all the way down to .192, and then 224, and then 256. Sorry for the sloppy, I'm using a mouse. Okay, so you figured out the network setup for this LAN up here. So, in judging at the IP address 199, you know that they're in this network right here. Right? 192, well, 199 comes after, so that's right. So it wants to know if PCs can connect to .193 to 223. Okay, yeah, at first glance that sounds right, because 192, so 193 is smaller than, or is bigger than 192, smaller than 224. 223 is smaller than 224, but what's the last IP address in a network? It's the broadcast, so you can't use it, because that's used for broadcast, exactly what it is. Like, you can send messages to all hosts on the network. So no, you cannot use this scheme right here. If it was 222, then yeah, sure, you can use it. So you guys really gotta watch, because they're pretty tricky like that, and they'll catch you on questions like that and through the exam. So just to keep your eye out for things like that. Okay, so I guess we're going on to E now. So PCs that are added to R1 can use any IP address between 193 and, oh well, I should have just kept that network. I wonder if I can, there, sweet. Okay, so what we're gonna do is I'm gonna clean this up a little bit here. Okay, it's all cleaned up now. So we were on question E. So the new PCs that are added to the LAN off router 1 can use any address between 193 and 222, except from 191 and 192. So that's pretty much the same question, only confirming that it's 222, right? Because 193 again is in this network, and 222 is in this network also, and it is usable. They're just trying to throw you off, well, except with .199 and .201. Yeah, okay, they're in here somewhere, but who cares? So yeah, you can, that's valid. So for question F, let's walk through that right now. And I hate Microsoft Paint. It's not bad, but okay, so for F, new PCs that are added to the LAN off router 3 can use any IP address between 129 and 158. Sorry for the reference, I'm just saying the last octet because they're all Class C networks. Class C, if it was lower than Class C, they would be, this number would be smaller than 24. But they're all bigger than 24, so right away it's all Class C network setup. So whatever, it wants to know if people can use 129 through to 158. And we got a -28 subnet mask. So 28, if you continue the count here, is 25, 26, 27, 28, which is 16. So this is our magic subnet now. 16. It's the last question, so I'm going to get sloppy. So our network goes up by 16. So again, we go 192.168, and they got 200.0, and it goes, 16, 32, all the way down to, what do they want to use? 193 to, 120. Wow, 129 to 256. So we could put network 128 to 144 to 160, and we can stop now because you can already see that the two addresses are in two different networks. So the 129 address would be in this network here, and the 158 network would be in this network here. And like I said, you can't use addresses in two different networks on the same LAN, so F is wrong. You fail. Okay? So now we can check to see if we've covered everything and to see if we're right. We can just show the answer down here, and you answered this question correctly. But I'm kind of glad because it was a good question to go through. It really explained a lot about subnetting. So what I meant earlier about this video being Class C related up here, it just meant like these bits here, how they go. Let me just show you, because this is how I learned subnetting. I just memorized this. I wrote out the first bit, so I went 128, 64, 32, 16, 8, 4, 2, 1, and I would issue the ID, so 25, 26, 27, 29, 30, 31, 32, and then I would write the values, like I forget the actual term of them, but when you add them up, like sometimes when you see the subnet mask like this here, 128 and 192, when you see subnet masks like that, so what that is just adding these up. So this one is 128, 192, 224, 240, 248, 252, 54, 255. But that's for Class C, so you'd have your dot here. And if their IP address was, let me just use an example, 192.168.0. Just to keep it simple, I'll go 18. Okay, so what that 18 means, so this is their subnet mask, that's 255, 255, 255 right here. So those are all ones, there's a whole bunch of ones. There'd be 24 ones here for sure. And then 18, it would hit a 0 for this. So the first bit is not on because this doesn't, 128 is way too big. 64, no. 32, no. 16, okay, so there'd be a 1 there. because 16 is smaller than 18. So you're trying to calculate, you're trying to add these up to make this number. So 16 plus 8 is too much. 16 plus 4, still too much. It's not 20. So 16 plus 2, well, yeah, that's 18. So that's what it would look like in binary. That's what you call binary, and that'd be a dot there. But that's just for Class C networks. This here. It all stays the same. Like the bit values, like the way the networks go up, will always be by this value here, 128, 64, 32. You know, you're not going to get a network that goes up by 10,450 million. Like, so it follows this pattern. What will change will be your ID here. So for B, you got, you know, a Class B network is 16 bits. So your first 16 bits, I'm not sure if I didn't even count. So let's just say that's 16 bits. And then the rest would be zeros. Until you reach 32. Like you can only have 32 bits. Okay? So if you were dealing with a Class B, what would increase would be your hosts. So your network would stay the same, and you know, like with, let's say for instance this network here, you can have 128 hosts per network. Okay. But so a Class B, what would, like these numbers here would keep adding up and doubling. So Class B would start off with 256, and then it would go to 512, and then it would go to 1024, and it would go to 2048. And it would just keep going and going and going until you reached all the way to the end. Okay? So I know if I'm getting a little sloppy here, I didn't really intend to get this far into it. I just figured I'd keep going. So if you pick it up, you pick it up. If not, then whatever. And your values would still be the same. So this would still be the first bit. This would still be the first bit. This would be the second bit. This would be the fourth, and then 8, and then 16, and then that would keep going following this pattern here. And so that would like initiate your networks, you know what I mean? So like you would start off, like, see, Class C starts here, so 24 would be this guy starting here. So this one would be 23, 22, 21, 20, 19. So then if you've seen like a like an IP address of 192.168.42-21, well then you know it's this. Okay, so it's 21. So your network goes up by 4, and you can have 1,024 hosts per network minus 2. So 1,022. And what that means is, like, keep this in mind. I'm going to refresh this here and get rid of everything. So if your network goes up by 2 or by 4 and you're dealing with a Class B network, because I know this is a little confusing at first, so you've got 10.1.1.0. Okay, Class B is these two. Okay, that's your class B network. So let's say you're in this network, the 1 dot network, it'd be 10.1.0.0. And you can go, when it says you got 10,000, hosts, you can go up each of these octets 255. So your next IP address would be 10.1.0.1 and then 10.1.0.2 all the way up, .3, .4, all the way up to 255, and then you would start in this one. So your next network would be 10.1.1.1, 10.1.1.2 until this reached 4, and that would indicate your network going up by like 4, and that would be the next network, 4.0, and then it would start all over again. So it just means you have a lot more hosts. That's all it really means, but you can still use the same setup. You can always just come in, start writing your binary. So you got the first bit, second, third, fourth, fifth, sixth, 7, 8, 9, 10. You can keep going until you reach 32. And then you can start labeling them out. That's what I do. That's what I'm going to do. I'm going to write my exam actually this Saturday. And when I walk into that room, it's not cheating, and I'm writing out my little chart here. So if I get a subnetting question, you can take half the time out of it. The hardest part is just multiplying the network. So if it goes up by 16 to go 0, 16, 32, 48, 64, 80, etc., etc. But anyways, I'm out. This I've really dragged on here at the end, but hey, if you picked it up, if it helps, I find that's the best way to subnet, is just to memorize that little chart. And like I said, once you actually write that chart down and see the pattern, you're gonna thank me for this. All right, thanks guys.